Applications of integration, page 9. Number 1, find the volume of the solid formed when the following are revolved through 2 pi about the x-axis. Okay. So, for C, the function they're looking at is y equals x cubed. And basically y equals x cubed kind of looks like a parabola, except for the right half is turned up and the left half is turned down. And if you're looking at from 1 to 2, basically it's like, you know, this section here. And so, and then if you rotate it, then you're going to have kind of like a little disc like this. And the disc has like a fatter part to the right and a skinnier part to the left. Looks kind of like that. Okay? And so to do this integral, we're going to integrate from here to here, which is from 1 to 2. And we're going to have the cylinder equation, pi r squared times h. And remember, h is going to be substituted by dx, because we're going to cut this up into little discs that are dx height. And the r squared is going to be the function here, which is x squared. So we're going to replace the r squared with the r with x cubed, but then we're going to square the x cubed. So it's going to be x cubed squared, which is x to the 6th. So then we're going to take the integral of that. The integral of pi x to the 6th is pi x to the 7th divided by 7, and then we're going to evaluate it from 1 to 2. And then we're going to substitute in 2, and then we're going to substitute in 1, and we're going to subtract them from each other. So we'll have pi 2 to the 7th over 7th minus pi 1 to the 7th divided by 7. So 2 to the 7th is it's like 128. So 128 pi minus 1 pi is 127 pi, and it's divided by 7. Okay. What about E? E is x squared, and we're going to evaluate it from 2 to 4. So that would look kind of like this. It would be like 2 to 4. And it looks very similar to the last one we did. So when we rotate it, it's also that shape, same kind of shape. And the integral is kind of looks the same too, except we're going from 2 to 4 now. And then we're going to put pi, and the r in this case is x squared squared, which is x to the 4th, and then dx. And then the integral of that is x to the 5th divided by 5. And then we got, we're going to evaluate that from 2 to 4. Oh, don't forget pi. So it's going to be 4 to the 5th power is like 256 times 4. It's 1024 pi divided by 5. And then if we put 2 in there, it's going to be 2 to the 5th, which is 32 pi divided by 5. 1024 minus 32 is, what, 992? Is that right? Divided by 5 pi. Okay. That doesn't look like a pi. Alright. Last one. 1 over x minus 1. That looks like hyperbola. Let's graph a few points. If we put 0 in, it's going to be 1 over 1. If we put 1 in, it's going to be 1 over 0. Oops, that's the asymptote. If we put 2 in, it's going to be 1 over 1 also. If we put 3 in, it's going to be 1 over half, which is 0.5. So basically, the part that we're looking at is this part here. So it's going to be like that. And then if you rotate it, it looks kind of like that. Okay. So the integral is going to be from 2 to 3 pi, and the r value is going to be 1 over x minus 1 squared. So I looked at this a little bit, and I think that if we rewrite this in a different way to use the inverse power rule, that maybe this is not so bad. So look at this. It's like this is the same thing as if we had 1 over x minus 1 squared, right? And then what if we rewrite this as pi times x minus 1 to the negative 2. And then we could, I'm going to make this all a little bit smaller so that we can get this out of the way. Okay. Then we could use the power rule, inverse power rule. So instead of negative 3, we would have negative 1, right? We would raise the power by 1, and then we would divide by the exponent, okay? And then we would evaluate that from 2 to 3. So first we would put, and we could simplify this. We don't need this negative 1 here. We could just put a negative here. That doesn't look very good. I'm going to put negative pi. Negative pi out front. Okay. So I'm going to have, I'm going to put 3 in there. I'm going to have 3 minus 1, which is 2, to the negative 1, which is 1/2. So we're going to have negative pi over 2. Then I'm going to subtract a negative, so it's going to be plus, and I'm going to put 2 in there. 2 minus 1 is 1, so it's plus pi. So the answer is going to be pi over 2. Pi minus pi over 2 is pi over 2. Okay. 2. Use technology to find, correct to 3 significant figures, the volume of the solid of revolution formed when the functions are rotated through 360 degrees about the x-axis. Okay. So maybe this function is not integrable, but it's okay. We can use the calculator. Okay. So this function, who knows what it looks like? Oh, we got the calculator, so we can see what it looks like. We're just going to put it in here. So for y equals, we're going to put in this function, which is x cubed divided by x squared plus 1. X cubed divided by x squared plus 1. Plus 1. Okay? And then we're going to integrate this from the limits 1, 2, 3. First we'll graph it. It looks, from this point of view, it just looks like a big straight line, but I'm sure that if we zoom out, it's going to be more curved. So we're going to draw a line like here, and then we're going to rotate it around. And the way we do that is we are going to rewrite the integral like this. Let's see, we're going to have pi, and then we're going to have x cubed divided by x squared plus 1, and this is the radius, and we're going to square it. And the h is going to be dx, and we're going to integrate from 1 to 3. So let's rewrite this function here, because we're going to integrate now. We're going to put in a pi, and the pi is blue, that button. So we have pi now. Instead of having just x cubed, we're going to actually have x cubed blah 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 blah, and we're going to square the whole thing. Squared. Oops. Squared. Oops. Oh man. Okay, I retyped it in after I accidentally erased everything. There you have it. Pi, parentheses, x cubed divided by x squared plus 1, parentheses, parentheses, squared. Now, even if you graph this, this doesn't really correspond to this function. This function is actually kind of a flat function, which the area happens to be the volume of the rotated cylinder. It's kind of hard to understand what that means, but we're going to integrate this function from 1 to 3. We're just going to do exactly what it says here. So to integrate it, we use second calc, integrate, which is 7, and we say we're going to integrate from 1 to 3. 1 is the lower limit, 3 is the upper limit, and the answer is 18.6. Okay? Oh, yeah, 3 significant figures. We gave it. All right. Moving on. Find the volume of revolution when the shaded region is revolved through 2 pi about the x-axis. Okay, so these we don't need the calculator. We can do by hand. And when you rotate this, it looks kind of like this. It looks like a little cup on its side. So let's see. It's going to be integral from 0 to 6 of the function, which is x over, oops, I forgot the pi, first pi. Pi times x divided by 2 plus 4 radius squared times dx, which is the height of the cylinder. So first thing we're going to do is we're going to multiply this out, because we don't know how to take the integral of something. Well, maybe we do, but I think it's easier if we multiply it out anyway. So let's go ahead and multiply it out. So we're going to have x squared over 4 plus 2 times 4 times divided by half. It's going to be 4x plus 16 dx from 0 to 6. Okay. Make sense? Just going to make it a little bit smaller. Alright. So we're going to integrate each term. Integral of x squared divided by 4 is x squared divided by 8. Integral of 4x is 4x squared divided by 2, so the result is 2x squared. The integral of 16 is 16x. And then we are going to evaluate that from 0 to 6. If we put 6 in there, it's going to be pi 36 divided by 8 plus 2 times 36. Oh, I did something wrong. Look at that. The integral of x squared divided by 4 is going to be x cubed divided by 12, right? Okay. Now let's substitute in the 6. So 6 times 6 times 6 divided by 12 would be 6 times 6 divided by 2, which would be 18. So the first term would be pi 18. Second term, 6 squared is 36 times 2 is 72, so that would be pi 72. 16x would be 16 times 6. Let's see, 16 times 6, that would be 96 times pi. And then if I subtract with the same expression with 0 substituted in, it would be minus 0. So basically I need to add up all these pi's here. 18 pi plus 72 pi is 90 pi, plus 96 pi is 186 pi. Okay. This one here, e to the x, it would look kind of like that. We're going to integrate from 0 to 4. We put in the expression e to the x. Oops, we forgot to put the pi again. Pi times r squared, which would be e to the 2x because e to the x squared is e to the 2x dx, which is the height of the cylinder. Take the integral of that, e to the 2x divided by 2, integrating from 0 to 4. Substitute 4 in there, and you get e to the 8th. Pi e to the 8th divided by 2. And if I put minus 0 substitute in that, e to the 0 is 1, so it would be pi over 2. Okay. And if you want to simplify it, it will be pi e to the 8th minus 1 divided by 2. Something like that. Okay. And that's it for page 9.